Hey everyone, in this video we are going to be talking about the unit circle and how that relates with our 45, 45, 90 special right triangles. Now the unit circle is something that typically gets introduced into Algebra 2, but you really focus on in a pre-calc setting classroom. So we're going to do a brief overview of it for now, maybe go a little bit in depth later. So remember we did this in our last video, trig ratios of any circle. The circle has a radius r, and any point on the circle is x comma y. In the unit circle, our radius is always 1. That's a huge idea. The radius is always 1 in the unit circle. Now, what we're going to be doing is talking about how these relate. So remember our triangle that we can draw in by drawing a perpendicular down. We create a right triangle. This is always x, y, and r, which is 1. So the sign is y over r, y over 1, or just y. Like I said, when you focus more on the unit circle, you're just going to know that the sign is always the y value. Cosine, it's going to be the same idea. It's going to be x over 1 or just x. Tangent doesn't really change. Cosecant, it's going to basically be 1 over y. And secant, the reciprocal of cosine, is basically going to be 1 over x, meaning flip the x and the y value. Now, how we find designated angles in a general circle. The first thing we're going to do is we're going to draw the angle in standard position. If it's in radians, remember we need to convert it to degrees first, unless you have your radian measurements memorized, which we do so many of these that eventually you probably will. We draw in the reference angle. From that reference angle, because it's always going to be 30, 45, or 60. In this video, we're going to focus on the 45. The next video, we'll focus on 30 and 60. We're going to draw the reference triangle, so we need to remember to have our side lengths memorized for a special right triangle. Find the designated trig function. Things to consider. These are two mistakes that a lot of people commonly make. You need to watch your signs. If you are in quadrant 1, every x value and every y value is positive. So your signs are going to be positive, positive. If you're in quadrant 2, that means you're moving left and up. The x value should be negative, the y value should be positive. If you're in quadrant 3, you're moving left and down. Those are two negative directions. And if you are in quadrant 4, you are moving right and down. So it's positive and then negative. Watch the signs every single time. The hypotenuse, the radius can never be negative. So the first thing that we're going to need to know is our side lengths for our special right triangle. Remember, we label them as x, x, and x radical 2. These aren't super helpful for us, so we're going to give it the easiest numbers that we can work with. The easiest x value that you can use is an x value of 1. So that means it's 1, 1, hypotenuse of radical 2. All right, so a 45-degree angle is in the first quadrant, and it looks like that. So I draw my angle in, and then from there, I draw my perpendicular line that goes down. This is a 45-degree angle, so it's a 45, 45, 90 triangle. My side lengths are 1, 1, and radical 2. I'm in the first quadrant, so I moved right and up. Everything should be positive. Remember, your reference angle, or what we allow to be theta, is always the angle that's next to the origin, or next to the center here. So my sine, remember in SOHCAHTOA, is the opposite over the hypotenuse. We can also say that it's the y over the r, which is 1 over radical 2. Big problem is a radical in the denominator. We rationalize by multiplying by radical 2 over radical 2 to get an answer of radical 2 over just 2. For the second example, secant of negative 135 degrees, that's in the third quadrant because remember, negative angles move clockwise. So if that is negative 135 degrees, I have 45 more degrees to go to the x-axis. Remember, you're drawing up or down to the x-axis each time, never the y, always the x. Side lengths in a 45, 45, 90 are 1, 1, and radical 2. Watch your signs. From the origin, I've moved left and down. Both ones need to become negative. Hypotenuse is never negative. It wouldn't make sense to have a radius of a negative value or to move diagonally negative. Remember, hypotenuse is always positive. So secant is the reciprocal of cosine. Cosine is the adjacent over the hypotenuse. So this is the hypotenuse over the adjacent, or r over x. Either way that you want to think about it is totally fine. This is radical 2 over negative 1, which is just negative radical 2. And 3 pi over 4, the tangent of 3 pi over 4. Issue here is that we need to know what this is in degrees. As I said, eventually the more you do these, you're going to be able to tell me what this is very, very quickly. But we're going to practice our converting for right now. So I multiply it by 180 over pi. My pi's cancel. 4 divided by 4 is 1. 4 divided by 180 is 45. 3 times 45, this is a 135 degree angle. So 135 degree angle is there. I draw up or down to the nearest x-axis. That gives me a reference angle of 45. Side lengths are 1, 1, and radical 2. Last thing we do to be safe is we check our signs. I've moved left, so this one needs to become negative, and up, so the second one stays positive. Remember, tangent is the opposite over the adjacent, or the y over the x, or 1 over negative 1, which is just negative 1.